All right, now we're continuing to do the log equations. There's 3 different ways that you can solve these. The first method is if you have the log on both sides, and the bases have to be the same, and they are base 10. You can cross these out and simply write the equation 5x equals 2x plus 9. And solve it. So subtract 2x from 5x. So you get 3x equals 9, and then divide by 3. X is 3. And there's your answer. Number 2, what are you going to do with this one? Cross out the log, so you have 10 minus 4x equals 10 minus 3x. Now, if you were to cross these 10's cancel. Negative 4x equals negative 3x. You would add 4, this is a goofy looking one. Add 4x here, so you get x is equal to 0. Number 3, cross what out? These logs. 4p minus 2 equals negative 5p plus 5. Add 5p to the other side, that gives us a 9p. Add 2 to 5 and you get 7, and divide by 9. So p is 7/9. Number 4, cross out what? Both logs. So you have 4k minus 5 equals 2k minus 1. Solving for k, subtract 2k, add 5, and what's k? 2. Number 5, cross out both logs. Negative 2a plus 9 equals 7 minus 4a. I'm going to add 4a to this side. Slow down. Okay. We're going to get the a's together. So add 4a to this negative 2a. So 2a plus 9 equals 7.
Would you subtract 9?
Subtract 9. So you get 2a equals what?
Negative 3?
Negative 2.
I'm sorry.
And then what's a?
Negative 1.
Yep. Okay. Number 6. I don't like this 2 times. How do I could back this up as a power, but there's something easier I can do. I can divide both sides by
2.
2. So those 2's cross out. So what you have is the log base 7 of negative 2r equals 0. 0 over anything is 0. Now this one you can't cross out that log base 7. So this is the second way to solve these. You want to rewrite this. Rewrite it as what? It's in log form, rewrite it in exponential. So what is that going to look like in exponential form? 7 to the 0 power is equal to negative 2r. What's anything to the 0 power?
0?
Nope,
1?
1. And then what?
Divide by 2?
By
Negative
what?
2.
Negative 2.
No, it's 1. Negative 1/2.
So think about is that one okay for everyone? Number 6? Okay, number 7. I want to get rid of this negative 10. So how can I throw this negative 10 to the other side? We're going to add 10 here, and whatever you do to one side, you do to the other. So you have the log base 3 of n plus 3 equals, what's negative 10 plus 10?
0.
0. Now, you can't cross that log base 3 out, because you don't have one on the other side. So you're gonna rewrite this as what? 3 to the 0 power is equal to n plus 3. And what is any number to the 0 power?
1,
Good. Then what do you do?
subtract 3,
Subtract 3 from 1, and what do you get?
n equals negative 2.
And isn't that the answer?
Yes.
It is. Number 8. I don't like this negative 2 in front. What am I gonna do? I'm
Get
gonna
rid of it.
divide both sides by negative 2. So I have the log base 5, 7x equals negative 1. Now rewrite this. 5 to the negative 1 power is equal to 7x. Well, what is 5 to the negative 1 power?
Negative 5.
1/5.
I'm sorry.
And now you should know how to do this. This is a simple, you're gonna multiply by 1/7. So 1/35 is equal to x. Number 9. Okay, we can't cross this log out. But I have a 2 here. See, this is not in parentheses. Since it's not in parentheses like that is, you can get rid of this 2. How are you going to get rid of that 2? Subtract 2. So you have the log, it's base 10, negative m is equal to 4 minus 2 is 2. Now rewrite this. It's 10 to the second power is negative m. And 10 to the second power is 100. Divide by negative 1, and m is negative 100. Number 10, what should we do with that negative 6? Divide by what? Negative 6. So you have the log base 3 of x minus 3 is equal to what's that? 4. Now rewrite this. 3 to the what power? 3 to the 4th power, which is 81. And now add 3 to 81 and you get 84. Two more. This is going back to the first 8 problems. What do I have the right to do right now? Cross out both log base 12s, 1 for 1. So you have v squared plus 35 equals negative 12v minus 1. When you have a variable squared, that's the degree of the problem. This is called a quadratic. When you have an x squared or a letter squared, you want to set one side equal to 0. So I'm going to move these 2 pieces to this side. So everyone look at negative 12v. What does negative 12v look like on that side?
Positive.
Yeah, 12v. And what do I do with this negative 1? We're going to add 1 to 35 and you get 36. Now you should see that this is a trinomial, and what do we do with trinomials with degree of 2? We first try to factor them. Do you guys know what 2 numbers multiply to give you 12 but add be 6? So there's one answer, and that's -6, because they're both the same. And the last one. This, you can cross out these log base 9s. Now my x squared is on the right side, so I'm gonna zero this side out. I'm gonna put a big fat 0 here. So -11x, if I bring this over to this side, it's gonna be +11x. And I'm gonna subtract 2, this has gotta go to the other side. This 30 is gonna be 30 minus 2, which is 28. My zero's on that side. So if I were to factor this trinomial, what two numbers multiply to give you 28 but add to the 11? 7 and 4. So my two answers are -7 and -4. And they both work. We didn't talk about extraneous solutions, but an extraneous solution will occur if you were to plug any of these numbers in, these solutions, and generate a negative number here or a 0.
Row x plus 7, but then row x equals
Yeah, the factors are +7 and +4. But when you set this equal to 0, it's -7. It's the opposites of those. Okay? That was your homework for today.